Bismillahirrahmanirrahim. Students, bulky dear students, we are going to study about the geometric distribution. This geometric distribution will be explained to you by relating it to the binomial distribution. Okay. Now let me tell you how do we write the binomial distribution. The binomial distribution is determined or defined by its parameters, which are the number of trials n and the probability of success, which is p. And this geometrical distribution is written as x is geometrically distributed with the probability of success p. So the first main difference you see over here, that you are given the n. This n is defined in your binomial distribution. Okay. Now, let me just write some points over here so that you can note them down. Okay. So here your n is defined or determined. We know that n. This n is not defined here. Okay. And this can go up to infinity. This n, thank you Tanveer bhai. Okay, now this can go up to the infinity in case of a geometric distribution. Okay, the rest is somehow the same here. This p is constant. Okay, and here this p is also constant. Okay, before that, I must have told you that we have two outcomes, just two types of outcomes here, okay? And which are like, the success and the failure. We have the same here, two outcomes in this as well, okay? The success and the failures, okay? And here, the number of trials or the trials, they are independent, okay? Or we have independent events over here. These events are independent, okay? And here we have them independent as well, okay? And we have the discrete number of events happening over here, and we have the discrete number of events happening over here, okay? Now, the formula for this was that the probability x equal to r, that was NCR, p raised to power r and q raised to power n minus r. While in this case, the probability x equal to r is going to be q raised to power r minus 1 times p. This really looks to be a very weird kind of a formula, okay? Now, before I tell you actually that what is this geometric distribution about, I want you guys to see that there is an interesting thing. This formula resembles with one of the formulas you have studied in your P1. And this also resembles with one of the formulas that you have studied in your P1. And I would like to see that who identifies or who is the one who recognizes this first, that to which formula this is going to resemble. Yes, anyone? Be quick.
Binomial expansion.
Yeah, the binomial theorem, okay? There you had the formula, which was TR plus 1, that is NCR, A raised to power n minus r and B raised to power r. You see the difference here? Here this A has n minus r, here this Q has n minus r, okay? Who will tell me that to which thing, what this resembles, this thing? The hint is this geometric. Yeah.
Geometric progression.
Mashallah, that's great. So you have the formula there, an, that is a raised to a, and then r raised to power n minus 1. So this really resembles with that, okay? So now let me take you guys to in the detail of this. Okay, I've told you about the similarities and the differences between these, the binomial and the geometric. Now let me actually go into the details of this geometric distribution. Acha bacho dekhiye, if you people recall your binomial distribution, like suppose if you are going to toss or roll a die. Suppose you have x is binomially distributed, this is 5, and this is 1 over 6. We're going to study the number of sixes, okay? And you have to find the probability that x equal to 1. So this is 5c1, 1 over 6 raised to power 1, and bacho 5 over 6 raised to power 4. Okay? Now, if you have, let's say there is a geometric distribution, okay, and you have this, you're rolling the die here as well. Now, if you're going to find probability x equal to 1, that would simply be 1 over 6. That means you're going to have the 6 in the very first row, okay? If you want to find the probability x equal to 2, oye bachcho dhyan se, this x equal to 2 means that you're going to get the 6 on the second row. If you're going to get the 6 on the second row, this means it was not 6 on the first row. So this was going to be 5 over 6 times 1 over 6. Then if you want to find the probability that x equal to 3, so this means this is going to be 5 over 6 times 5 over 6 times 1 over 6. Like probability x equal to 3 does not mean that there are 3 sixes. It means that the 6 is happening on the third row. Okay. If you want to find the probability x equal to 4, so that would be 5 over 6 cube times 1 over 6. It means it was not a 6, not a 6, not a 6, and then it was 6 on the fourth row. Okay? So there is no problem. There is nothing to be worried about the different possible arrangements or the things, orders in which this is going to happen. Okay, this is simply a 6. Let me use a different color. In this case, this was simply S for the 6. This was not 6, and then it was a 6. It was not 6, not 6, and then it was the 6. Okay, and in this case, the first 3 throws didn't show the 6, and we were getting the 6 on the fourth throw. That was S over here. Okay. Now, my question to you people is that why do we have 5C1 in case of this binomial, but why this is missing in this in case of this geometric distribution? Yes, please tell me.
Sir, we don't have n.
Very good. That is one of the reasons. Any other reason? Yeah, can you think of elaborating this 5C1? Guys, this 5C1 actually in case of this binomial distribution means that it can be a 6, not 6, not 6, not 6, not 6. And then this is 6, then not 6, 6, not 6, not 6, like this. Hannah? So these are the different situations, different possibilities of this 1, 6 to happen out of the 5 throws. So these 5 situations are basically 5C1. They are same as 5 factorial over 4 factorial into 1 factorial. Like when you're going to roll the die 5 times, so how many times you have 1, 6? So these are the different cases when it happens. So that is why you're using NCR in this binomial distribution. Since you look at this, when this is going to happen for the very first time, this is simply S. For the second time, S dash S. For the third time, so this is the only possible arrangement over here. So this NCR is not required in this geometric distribution. Is that clear to you, bacho?
Yes, sir.
Yes, sir.
Okay, bacho. Now let me take you to the questions now. Okay, I'm going to clear this. I'm going to clear this.
Sir?
Okay. Yes, beta.
सर यानी कि ये जो ज्योमेट्रिक वाला है उसमें हमने ऑर्डर नहीं देखना, यानी कि सिर्फ थर्ड टाइम पे देखना है, लास्ट टाइम वाला।
Last time पे, very good, very good. Abhi, let's see. Please keep your questioning thing open on. Okay. There would be situations over here that will not be clear to you, so you have to be very alert, very responsive. Okay. I'm going to keep a question in front of you, and then you guys will be asking, or you will be trying this. Um, Okay, here is the question. You guys try it, and then I'll explain this to you. Okay, now let's discuss. It says repeated independent trials are carried out in which the probability of success in each trial is 0.66. Okay, so I'm going to write this as X is geometrically distributed with this 0.66. That means your P is 0.66, okay? And your Q is going to be 0.34. It says find the probability that the first success occurs on the third trial. But the first success occurs, look at the wording, the first success occurs on the third trial. Okay, so this means we have to find probability X equal to 3. The formula is that when you have X is geometrically distributed and you have the probability of success, so probability X equal to R is Q raised to power R minus 1 times P. Okay, so it says it is going to happen on the third throw, or the third try. So this means this is going to be 0.34 square times 0.66. If it's clear, can I go on to the B part?
Yes, sir.
Okay, it says on or before the second trial. Now we know that he's telling us the second trial. So that means there are possible 2 maximum trials there, okay? So that means probability X equal to 1 plus probability X equal to 2. That is on the second trial, and before the second trial, that is obviously the first trial, okay? So this would be, when it's a first trial, this is simply 0.66. When it's a second trial, the second trial can only happen if you have failed in the first attempt. This is going to be 0.34 times 0.66. Okay, and you can find the answer. The C part, it says, in the C part, it says, after the third trial. How should I write this after the third trial?
Greater than or
X is
equal
greater
to
than
4?
3.
Very good. This is probability X is greater than 3. This is just greater than 3, okay? Acha, bacho, I have come to the conclusion that if I tell you how to find this to the number line, you will understand this easily, okay? Now this is your 3 and this is showing greater than 3. Up to what this arrow can go, bacho, if it says greater than 3?
Infinity.
Very good. So we can't go up to infinity. So what is its complement? What is the complement of this diagram right now?
Less than 3 हो जाएगा तो 1.
Can I say this is 1 minus probability X is less than or equal to 3?
Yes, sir.
Anna? If this all is our diagram, our situation here, we want to find all this, okay? And we know that the sum of the probabilities, it is always equal to 1. The sum of the probabilities is always 1. Okay? So since we have to find this is going up to infinity. So we can find this and then subtract that from 1. Kyun bhai? Yes, bacho? Acha. Now, this is going to be 1 minus probability X equal to 1 plus probability X equal to 2 plus probability X equal to 3. Okay? Acha. But ये बताओ कि if you have, you know that you're going to do an experiment 3 times. You are going to repeat something 3 times. And you are dealing with the geometric distribution. What are the possibilities if you are allowed to do, for example, your parents say, okay, beta, we are giving you 3 chances to get a certain score in your SAT. Okay. So you can get that score directly in the first attempt. You can get to that score in the second attempt. For example, if God forbid you fail in the first attempt, then you will be going for the second attempt. Okay. If you get that score, you don't need to go for the third attempt. Now, for instance, if you fail in the first 2 attempts, then you will be going for the third attempt. And if you're a student like me, you might fail in all the 3 attempts. Okay? So this is what going to happen if you are appearing in a test for the maximum 3 attempts. Okay? Now, here, this shows probability x equal to 1. This shows probability x equal to 2. This shows probability x equal to 3. And here, obviously, the success is not happening. Now, what is the sum of all these 4 events? Be quick, bacho.
1.
1. Very good. Now, can I say this Q is going to be 1 minus probability x is less than or equal to 3? Yes or no?
Yes.
Yes. Now, can I write this value as simply, since we have 1 minus all these 3 happening, can we simply say this is going to be 0.34 raised to power 3? Yes or no?
Yes.
Yes. Okay. Now the time to check the answers. Okay. If you have used the calculators, yes. The first part is this. It seems to be correct. Okay. This seems to be okay. The second part, if you have, I think this should be okay because it's doing the same. Okay. The third part, yeah, he's doing the way we have done this. We have been a bit smarter. Can you please find 0.34 whole cube quickly and see if it is really 0.0393?
जी sir.
Yes. Okay. So we can move to the next question now. This is the next question that you guys will be trying. Chale, you try this question. It says in a particular country, 18% of the adults wear contact lenses. Okay. And adults are randomly selected and interviewed 1 at a time. Find the probability that the first adult, he says the first adult who wears contact lenses is one of the first 15 interviewed. Okay, so I'll be starting by saying X is geometrically distributed with this 0.18 as my probability of success. Okay, so this P is 0.18 and this Q is going to be 0.82. It says, find the probability that the first adult who wears contact lenses is one of the first 15 interviewed. Okay, so this means N is defined here. N is going to be like up to, this is going to be less than or equal to 15. Okay, so it's saying find the probability that X is, I've written greater than, sorry, this is less than or equal to 15. Okay, so this is probability X is less than or equal to 15. First of all, you must be convinced that this statement has been written as probability X is less than or equal to 15. Yes.
Yes, sir.
Anna? Acha,
Yes,
to
sir.
make you understand this question, I'll go back to that situation that, for example, you're appearing in a SAT test for 5 times, okay? And you're passing in one of the first 5 tests, one of the first 5 attempts. Let me say this more clearly. Okay, you're going to appear in a SAT test maximum 5 times, and you define the probability that you pass in one of the 5 attempts. Okay, so that means probability X is going to be less than or equal to 5. Can I say this is going to be 1 minus q raised to power 5? Yes or no? Look at this, how this would happen. You can pass your exam in the first attempt. You can pass in the second attempt. You can pass in the third attempt. You can pass in the fourth attempt. You can pass in the fifth attempt. And if it's a student like us, so he will not be passing at all. Okay, so these are the cases where the student is passing in one of the 5 cases, while the sum of all of them is 1. So we need to find this probability. So the simpler way is to find 1 minus q raised to power 5. Do you agree with me or not? I'm waiting, guys. We just have 6 minutes left. Please be quick. So this should be
Yes, sir.
1 minus q raised to power 15, which is basically 1 minus 0.82 raised to power 15. Okay, now look at it, says but B part, not one of the first 9 interviewed. Okay, so for this I'll be showing you the number line. Okay, so this means this person is going to be somewhere in this region. He's not one of the first 9 interviewed. Hannah, so this means this is 1 minus the probability X is less than or equal to 9, which is asking for probability X is greater than 9. So this is going to be Q raised to power 9, or simply 0.82 raised to power 9. Let me check my working. Yeah, first one is right, okay. And the second one is also right. It's your time to ask if it's not clear. If
Sir,
you,
it's not clear.
okay, now
सर
look at
मुझे
this,
भी
it
नहीं
says,
समझ लगी.
मुझे भी नहीं.
okay, Pita, I'm going to make it clear. You be there, you try your best to understand this, okay? Now look at this. It says, now, are you not clear with the part A or the part B? Which part?
The A.
Okay, now it says one of the first 15 interviewed. Now, the example I gave to you that you're going to attempt a SAT test, okay? Your mother says, okay, look, I'm giving you 5 chances. So you pass it in these 5 chances, okay? So then you will talk to yourself that, okay, I have to do it, that this has to be within 5 chances. You have to do that, okay? This is where you're passing in the very first attempt, second attempt, third attempt, fourth attempt, fifth attempt. And there can be also the situation where you cannot pass in all these 5 attempts. This is your sample space. Do you remember the term sample space? All possible things happening within these 5 attempts. Okay? So if it has to be, suppose your mother is very generous, she gives you 15 chances, okay? So you want to do that within the 15 chances. So this means you don't want this to happen. Okay, you fail in all the 15 chances, है ना? So this has to be 1 minus q raised to power 15. Is that clear to you or not? Hello.
Yes, sir.
Okay. Now coming to the B part, it says, now, suppose your mama says, I know you're going to pass in more than 9 attempts. Okay. This is what your mama is saying. I know that you're going to pass in more than 9 attempts. So it means she is confident that you will be failing in all the first 9 attempts. Is it so or not?
Yes, sir.
Yes. So that
Yes.
is why we've written down q raised to power 9 over here. Okay. Now, at the time we are left with, it's not enough for to go to the next example. So I'm going to finish this here. So let's meet in the next session.